Hello everyone, in this video I want to address a rare issue that may occur when you're trying to join multiple DTM tiles in a single tile. In this project I've already imported all of the DTM tiles and you can see them listed here to the side. These tiles originally came in the XYZ format, and this is what this issue seems to be specifically related to, this format. So we're going to first of all see what the issue is and then how to fix it. So I've already just dragged and dropped these tiles in the project, and now if I go under the raster menu, miscellaneous, build virtual raster, this is the algorithm we will use to merge these tiles together into a single one. Under the input layers, I'm going to click on the ellipsis button to the far right, and then I want to select all of these tiles. So I can just click on the select all button and then go back under input layers. Everything else here can stay in default, and I'm just going to click on run. Now notice the error that is going to give us here in the log. It says that the algorithm does not support positive NS resolution. NS stands for north-south. So the issue is that these tiles have not been georeferenced correctly, and their origin point would normally be in the top left corner of each tile, but currently it is sitting in the bottom left corner. So the algorithm doesn't understand how to merge these tiles together. This can be very quickly fixed simply by warping these tiles and then maybe converting them also to a different format like GeoTIFF, and then we can merge them again together. So I'm going to exit out of this algorithm now. We want to open up the warp algorithm, so we can go in the bottom left corner of the interface and in the search field type warp, and there is this algorithm called warp reproject. We have to reproject each one of the tiles separately. So I'm going to start from the very top one here under the input layer. For source CRS, I'm just going to set the same coordinate system that the tiles already have. If I just mouse over one of these tiles, we can see that the coordinate system has already been assigned. It is the EPSG code 4487, and so this is the same one that we are going to use. It's already listed here. If you don't see it there, you can just click on the globe button to the far right, and then from no CRS, set this to predefined CRS, and then through the filter search field, you can search for the coordinate system that these tiles should have. If you don't know what it is, and in some cases the tiles may not have a coordinate system already assigned, then you can just quickly go to the website where you downloaded the tiles from and search for it there. It should be listed. Sometimes it is called datum, sometimes it's called CRS or something else, but it should be listed there. And then you can right click on any one of the tiles or even select all of them together, right click and go under layer CRS and then choose set layer CRS, and then simply search for the coordinate system through the filter search field. So this is the one that we are using right now. I'm going to go back, and for source I'm going to select the coordinate system, and for target the same coordinate system. The next thing that would be good to do is to change the format of each of these tiles to a GeoTIFF, and we can do that also during the process of warping. If you go down to where it says reprojected, there is this empty field, but if you click on the ellipsis button to the far right, you can choose to save to file. So I'm going to click on that, and I'm going to find a folder somewhere on my hard drive where I want to save these files to. The important thing is to go down here to save as type, and from this list, which will originally be set to XYZ, scroll to the very top and you're going to see the TIFF files or .tif. So select this one and then just give it a name. I'm going to call this DTM1, and each one of these tiles I'm going to simply change this number, so DTM1, DTM2, and so on. Now make sure that the open output file after running algorithm box is checked on, and with all of that done we can click on run. We can see that the DTM was processed and it was placed in the layer stack. Now we can simply go back here under the parameters tab and simply switch to the next DTM in the list, which is this one. Then scroll down, and under the reprojected field you can simply set a different number here for the name of the DTM, so you don't have to go through the whole process of clicking here on save the file. You can just set a new name from the field here, and then I'm gonna click on run and repeat this process until I have all of the DTMs reprojected like that. All of the DTMs were now reprojected, all 9 of them, so I'm going to close out of this algorithm. We don't actually need the original ones anymore, so I'm going to select them and just delete them. Now this fixed the issue that we had before, so we can actually use the merge algorithm here under the raster menu, build virtual raster. For input layers, again, I'm going to click on the ellipsis button, select all of these DTMs, and then just click on run. And you can see that we didn't get the issue and the merged DTM was placed here in our layer stack. So I'm just going to move it above everything else and close out of this algorithm. And here we have it. So we don't need these tiles anymore. I can just remove them. From here, you can just right click on this layer, go under export, save as, and save it as a raw data geotiff somewhere to your desktop just by clicking on the ellipsis button here under file name. I'm going to call this DTM_merged, click on save and press OK. And so there we have it. The DTM was now exported. From here you can proceed to do whatever you want with it, maybe export contours from it, or clip it to a boundary. And this is in fact something that the person who sent this project to me wanted to do, to clip the DTM to a boundary. So I'm going to quickly go through this. Boundary is here under a KMZ file. So I'm going to simply drag and drop this into QGIS. This pop-up window will appear, just click on add layers, and then we can go under the raster menu, extraction, and because the boundary is with a irregular shape, we can use the clip raster by mask layer. This is going to ensure that the DTM is clipped exactly to the extent of this boundary. If you use the clip raster by extent algorithm instead, it's going to clip the DTM to a regular boundary. So it's going to approximate the shape of this boundary and create rather a square looking clip, but we want to clip it exactly to the extent of the boundary. So I'm going to use the clip raster by mask layer instead. For input layer, we will select our DTM, and for mask layer, we want to select our boundary. Everything else here can stay as it is, and we can click on run. I'm going to exit out of the algorithm and disable our original DTM, and you can see now the DTM was clipped exactly to the extent of our boundary. So from here now you can proceed to extract the contours or whatever else you wanted to do with this DTM. Thank you very much for watching. I hope this video has been helpful, and we'll see you in the next one.